Hey, Susanna,
Hi,
how's it going?
it's great. Thank you. Thank you for inviting me.
No, no worries, no worries. It's 9 a.m. over where you are, right?
Yeah, exactly in the morning, and it's still dark outside and it's snowing, but that's great.
Wow, wow. So I thought I'd give everyone a bit of an introduction to who you are. Just for those listening in, Susanna has really pioneered some really amazing research. She's the first author on a recent paper of the Cell Press journal exploring the metabolic and other positive effects of repeated cold exposure and the combination of cold and heat for insulin management, increasing metabolism, and some other health benefits. So, Susanna, let my audience know, how did you become so fascinated into cold exposure?
Well, first of all, I started my research in something completely different, so it was kind of a coincidence that I just fell over this topic because another researcher was doing this research in brown fat. And the brown fat is a healthy fat that we have, which is burning our calories in our body when we get cold. And that works so very different from the white fat, which is storing
Mm,
our energy. So the brown fat can burn the white fat, and I found that very fascinating. So, and when the
mm,
research says that you need to get cold to activate your brown fat, we were thinking maybe we should do a study where we cool people in some way. And
mm,
there are already studies out there showing that if you cool people by wearing a cooling vest, then you can activate your brown fat. But I didn't find that very feasible to say to people you should run around with a cooling vest. So I was thinking, well, we live in Denmark here, and people are winter swimming here. So yeah, that's why winter swimming suddenly became a part of my study. So it's kind of a methodological approach to it. But in the same time, I became a winter swimmer myself.
mm. Yeah, it's really fascinating. Did you want to maybe explain to my listeners? We'll keep it really simple. Did you want to explain to people what actually happens to the body, once we undergo sort of cold therapy or we're experiencing cold?
Yeah, so it's so when you go into the cold water, you will have, if you are a new winter swimmer or you haven't really adapted to the cold, you will have a cold shock right immediately as soon as you take your clothes off and you walk in and you touch the water. You will start to hyperventilate. You can do
Mm,
something to calm that a bit with breath work, but if no matter what, if it's the first time, you will hyperventilate. Just mentally, you can prepare yourself so you won't panic at least. But you will
mm,
hyperventilate. That's normal. And yeah, what happens is that when you go in, the cold receptors in your skin will sense that it's cold, send a signal to the brain where we have this temperature regulating center. And
mm,
this center in the hypothalamus will sort of balance out, well, is this cold or is this hot? If it's cold, it will send out signals in the body saying, uh-oh, this is cold, we have to be careful. So these signals are norepinephrine, for example, which will make which will help contracting the veins in your capillaries, in your skin. So you will have all your warm blood circulating to the core of your body, because you need to keep your vital organs warm, right? So it's kind of
mm,
a fight and flight system. So it's the sympathetic activation of your central nervous system,
mm,
because we are trying to keep ourselves alive in this way. So,
mm,
so all the warm blood goes to the core, and you will then, if you manage to stay longer than 20, 30 seconds in the water, which you will not the first time, but if you can, after a few attempts, then you will feel that the immediate cold shock response will be lowered because of norepinephrine and because of endorphins in the body, and then you can calm your breath, and then you can stay in the water for a bit.
mm,
And
mm.
you will
I guess,
activate the brown fat, but I can come more into that. Yeah.
yeah, yeah. We'll circle back to the brown fat, but just elaborating on that norepinephrine release. This is possibly one of the reasons why people feel so energetic and alert following cold exposure, right? Like, so that neurotransmitter can play a role there.
Yeah, exactly. Yeah. So people get, so it's both norepinephrine and also a bit of adrenaline, not that much exactly, but it doesn't matter. It's the cold shock response, and it's the fight and flight system that you are activating. So your body will become very alert. And in the same time, you will always also have other transmitters released in the brain. So you will have the endorphins and the dopamine release, which will make you like happy and maybe a little silly afterwards.
Yeah.
We've seen that.
And so with the brown fat, obviously this is a hallmark benefit of cold exposure. And you mentioned that it can help to actually burn calories. Do you want to maybe elucidate some of the other benefits associated with having more brown fat?
Yeah, so there's been studies where they have looked at if we cool people, can they get more brown fat, and what happens when we get more brown fat? So the function of that. So we can increase the amount of brown fat. We've seen that in mice studies, we've seen that in human studies as well, both in lean, but also there's a few studies in obese subjects too. But if you are cooled, then you will boost your brown fat because you will have this release of norepinephrine, which activates the brown fat, and then we will have a browning of our other cells, which could be, now we have the whole color palette. So the base cells will become more brown, and the brown cells in humans will become more rich with mitochondria. So mitochondria is really those small fabrics that are activating our cells. So we really want more mitochondria in our cells, but and we have that in the brown fat cells. So when that's activated, you will it will use the fat in the brown fat cells as a fuel, and as soon as that's used, then it would take glucose and lipids from the bloodstream, and in that way it would clear up a bit from what we have left in our bloodstream, but also take from the white fat. So that is how we think that the brown fat can burn calories. And what we have seen in humans is that when we are cooled for long enough, there is a very nice study showing that if you sleep cold for a month at 19 degrees, then you will increase your amount of brown fat. And when you then, the month after, sleep at the 24 degrees, we can see on these PET-CT scannings where we can see the brown fat volume, you can see that it has decreased again. So so if you sleep cold, you can increase the amount of brown fat. And they also saw that the insulin sensitivity was increased upon that month of sleeping cold. So that was kind of the study that made me go into this winter swimming, because I was thinking maybe we can find another way to activate the brown fat besides wearing cooling vest or sleeping in a cold room at 19 degrees Celsius, which I think is a bit cold.
Yeah, can be a bit of a challenge for some people to get used to. But so, some of your other findings, I guess you also mentioned some interesting findings in trained athletes. Now, you compared the differences in trained athletes and also just normal people. So what did you find in athletes?
So I didn't study athletes. The study that I did was in healthy lean subjects with the average age of 24. They went training 2 to 3 times per week. But I mean, they are not athletes. They are just, I think, just healthy, healthy young subjects that I recruited. So I really wanted to do a study which was not in any way extreme. I wanted to find out with how little cold exposure can we actually get away with and still have health benefits. So that's why I came up with this protocol for the study, where they went to swim 2 to 3 times per week, and also they go into the sauna on those visits. So in total, it's only 11 minutes submerged in cold water per week, and 57 minutes in a sauna per week. So, and that's
Wow.
divided up, but you could also do it how you want it. But yeah, but we did see some really interesting results upon that.
Yeah, and I guess a lot of people will be wondering in terms of how cold it needs to be. So what did you find there?
Yeah, so just in general, we can say that the cold water is is 15 degrees and lower. So that's because there's studies showing that people who have been in cold water at 15 degrees and below, they have had some serious events. So you can say that it's cold enough to have a cold shock. It's also cold enough to injure yourself, so get hypothermic. So 15 degrees and below is Celsius. So that should be cold enough. It doesn't really, for a winter swimmer, it doesn't really seem that cold to be in 15 degrees, but you can say if you go to a lake or you go to the sea, it will vary upon the season, of course. So in the beginning, in autumn, it would be maybe 19, 15 degrees, and then it would decrease during the winter, of course. So if you want to do the protocol of 11 minutes, you should think about that as an average. So going into the water is not, I wouldn't say that you have to stay there for a certain amount of time. It's just important that you stay there until you are uncomfortable, but still feel safe, and then go up. And there's just trust that you will get adapted and trust your own body signals. So if you feel that this is not right, then go up again, because that's your body telling you that you need to get away. Also that to make sure you have a good experience, and then you can go again next time and increase the amount of time in the water. So
yeah, fascinating. And I guess those that have good tolerance to cold, would we suspect that they may have, a higher metabolic rate in a sense? Maybe they have better thyroid hormone output. Has there been any sort of correlation there at all?
Yeah, I'm not sure about that, but yeah. So if you are cold adapted, my studies show that I don't think it's been shown before, but if you get adapted to the cold water, my study shows that you have a higher metabolic rate. So the winter swimmers in my study were trained winter swimmers for a couple of years, so that it was their second season, you can say, so not very advanced trained winter swimmers, but they have tried it before, and they seem to have a lower insulin production. Yeah, so I measured that during multiple days just to see how that looked, both during cooling and during room temperature, and we saw that they had lower insulin production, but also when we tested the you can say their glucose tolerance, we gave them a glass of sugar, which they drank after fasting, of course, and then we measured the blood sugar and insulin, and we saw that the winter swimmers had a faster glucose peak, but also faster decrease again upon 2 hours. So lower glucose levels and a higher a lower insulin production than the control group, which were matched to the winter swimming group, of course.
Wow. Yeah, that's we can see how that can be applicable to, to the everyday person, I guess. Improving that insulin sensitivity is going to go a long way for a lot of people. There's something else that you also mentioned, and this is around that we do not need to submerge the entire body, and that we can just apply the cold to our hands and to our feet and even to our face. So did you want to explain that a little bit?
Yeah, so when you expose a body part to cold, the cold receptors will still signal to the brain, and you will have a release of norepinephrine, which will activate the brown fat. So if you want to activate the brown fat, you don't have to think about where is the brown fat located, and that particular area I need to submerge in the water. So you have brown fat up on your neck and under your supraclavicular bones. and down the spine, a little bit around the heart and the kidneys. But you don't have to submerge up to here to activate the brown fat here. It's that your nervous system will do the work for you. So so you really don't have to go all in. You mentioned the hand and the feet in cold water. So there's studies showing that if we submerge a hand or a foot in cold water, subjects who have been PET-CT scanned afterwards to see the activation of brown fat, we see actually that a foot is enough to activate the brown fat, and also a hand. So it's really efficient, you can say. So if you only submerge up to maybe here, it should be enough, and you don't have to go all in with the head. And because that will also give you an increased cold shock response. It could be dangerous also.
Yeah, I guess the main takeaway there is it doesn't have to be that extreme.
No.
It really doesn't. That's what you've concluded, is that we can get a lot of the benefits without having to suffer to the extreme.
Yeah. You can get away with very little time doing this, but you can also get away with just do it in your own tub at home. If you don't have the water or a lake nearby, you can buy a barrel and put it in your garden or on your terrace even, and do this cold exposure. So it's really feasible, if you ask me, with this protocol. So, and you will have some really quickly benefits from this. And I think it was surprising for us that we actually saw this in these healthy lean subjects, because they already were very healthy. They were already had a perfect metabolic rate. So how could we even improve that more with just going into the water 11 minutes per week and going into the sauna? So it's really a contrast therapy that we measured.
And as part of the cold therapy practice for like the everyday person, is it generally advised that if somebody were to engage in the alternate therapy between hot and cold, is it generally encouraged for them to finish on the cold? Is that the general rule of thumb, and allow the body to warm back up naturally?
So what I always say is that you should end cold if you do the contrast therapy. So you should start cold, because that's very good to just alert the body, and you will activate the metabolic rate. Then go into the heat if you have a sauna. That's really good. And then you can go in and out as many times as you like, of course. This protocol was based on going into the water, into the sauna, back into the water, into the sauna, and then ending cold, and then go home. Because if you end cold, then you will have to warm up by yourself. The body really needs to activate all the brown fat and also the muscles to increase the thermogenesis. So if you end in the sauna, you will probably have some other benefits from that, but you can say it's more demanding for the body to heat up by itself. So ending cold was part of my protocol. Yeah.
Makes sense. And as part of the exclusion criteria, like even sort of looking at the general population, is there a certain demographic that you would advise against the use of cold therapy?
Yeah, so there's generally rules or rule of thumbs that you can say if you go into the cold water and you are a non-adapted winter swimmer, you will have a small increase in heart rate and also blood pressure. And because you are activating both the sympathetic nervous system and the parasympathetic nervous system, there is a bit of a little conflict in the body for the heart. So the sympathetic nervous system wants to increase heart rate and the parasympathetic wants to decrease, right? So there's a bit of a conflict. And so if you have heart problems and you have high blood pressure, you should consult with your doctor first, maybe just asking, what do you recommend? Is it okay for me to go into the water, just for safety? And also for safety, I always say, don't put your head into the water. You really don't have to. It's not necessary, not for health benefits, but some people just like it. And yeah, that's up to them. Sometimes I just put some water in my face before I go up from the water, just to cool the face off.
Yeah. It can be tempting to want to show off in front of your friends, to duck under, and then you get out with, and then you've got brain damage or you've frozen your brain. So
brain freeze, but it's dangerous. I mean, it's studies. There are some good Danish studies actually showing that when you submerge people into, it was in a big tub in a lab, they did this experiment where they submerged people in those, and they looked at where the blood flow went. So they actually saw that 30 to 40% of the blood flow from the brain was actually away. So it was decreasing. So they got a little bit dizzy. So I think some winter swimmers who have dipped their head in the water might recognize that they have been dizzy or feeling a little bit of black in front of the eyes because of the decreased blood flow. And that could be a bit dangerous because you can faint, of course, and you can hurt yourself. If it's slippery and you are dizzy afterwards, you can fall. And there's a risk of drowning, of course. So I always advise also to never go alone. So always bring a friend, your neighbor, your sister, your mom.
Absolutely.
Yeah.
In terms of future research, Susanna, like what else are you really excited to see more of?
So after this study in the healthy lean subjects, I was really interested in seeing, so how does this look if you have a totally different metabolic profile? So I did a randomized controlled trial in obese pre-diabetic subjects, males and females, and men and women, because I wanted to see just the average middle-aged group. How does this protocol look in this group? So I repeated actually the study just in another group and in another age range, and also in people who didn't really have the perfect, you could say, metabolic profile. So to see, can we actually move this? Can winter swimming be a way of getting from pre-diabetic to down to normal glucose levels again, and insulin sensitivity. So that we are working on right now, and also to see if we can activate the brown fat in obese subjects who are more than 40 years old. So that's because brown fat is a tissue that is very abundant in healthy lean subjects, young subjects under 40 years old. But as far as we can see in already published studies, that brown fat is not that easy to activate in obese subjects, type 2 diabetic subjects also, but also if you're over 40 years old, there is a decrease in the activity, but also in the volume of it. So we are asking, why is this happening? So the metabolic rate goes down after 40 or 50 years old, right? So if we can activate the brown fat again, keep it alive, you can say, in middle-aged subjects, and maybe we can also prevent some obesity. We can prevent type 2 diabetes.
Wow. Was there any similar research, I guess, on obese, or is this the very first of its kind?
There are studies where they have scanned obese and type 2 diabetic subjects for brown fat, but nothing on winter swimming. There's nothing with the cold in that way. But they have cooled obese subjects and also type 2 diabetic subjects, and they see very little brown fat in these groups. But that could also be due to maybe not that efficient cooling protocols, because we need to cool the subjects and then for a certain amount of time, and then put them into a PET-CT scanner to see see the brown fat. If you go into my Instagram profile, I have some PET-CT scannings of the brown fat, so you can see the brown fat yourself. So if you do that, then you can see that the brown fat is most abundant here under the supraclavicular bones. That is probably the largest depot that we have. But in obese subjects and type 2 diabetic subjects, for some reason, it's not there, even maybe not anymore, or we are not using the right way of activating it, or it's not taking up the same substrate as healthy lean subjects could also be. So we are looking into this as well.
That'll be really fascinating. As soon as you publish some data on that, I'll be sure to share that on my cool. Instagram. That'll be interesting. A lot of people are asking the question around, can we still derive a lot of these benefits simply from having a cold shower? From what I understand, it does appear that there will be some crossover benefits, in terms of having a cold shower. So maybe did you want to elaborate a little bit more on that?
Yeah, so the cold showers is not exactly the same, but you are right that we can transfer some of the benefits, of course, and because cold is cold. But the thing with submerging is that you activate both the sympathetic and the parasympathetic nervous system, because it's your diving response actually that you are activating, which you don't in a shower. You will just have sprinkles of water on your body, and you will feel kind of like cold and hot and not really. Yeah, so it's not the same. And the thing, but if that's what you have, I think you should definitely do it. I think that cold shower is a really good way to also get started, to get some, you can say, resilience from that, and then maybe you can move on to submerging in a tub or in a barrel in the sea or lake or what you like, because I think that submerging is the most healthy way, where you get the most benefits, at least.
With that submersion process actually entering into the water, is there a particular reflex that's sort of activated by is there a known reflex that occurs in the body?
Yeah, so what do you mean?
As in like, with young babies that are born, if you tickle the base of their foot, they
Yes.
Is there I mean, do we have a name for that submersion reflex, or is it just that it activates both parasympathetic and sympathetic nervous systems?
That's the diving response, yeah. So it's a reflex, yeah. So and you won't have that in the shower. So it's yeah.
That makes sense. Okay. And as far as the brown fat, you said that in some diabetics and overweight individuals, they actually have less brown fat. What do we think might be the mechanisms, or what do we think might be some of the reasons
why they have less? So we don't quite know. It could be that with age that we get obese and our metabolic rate goes down. We get you could say less insulin is sensitive in our bodies, and that might slow the brown fat cells in some way. Or it could be that it's actually the thermogenesis, the brown fat, that is decreasing, and that makes it harder for people in the middle age to actually lose weight. So so we don't know if it's which comes first in this regard. So we don't really know yet, but it's really, really interesting, and we want to find out, of course. So what we are looking at is both to see can we actually activate the brown fat in obese subjects, and how much do they have? Can they get more function or more brown fat in tissue in volume? If we can do that, then there should be a turnaround. It should be possible, right? And also we are looking to see if we can find markers that are coming from the brown fat and circulating to the other organs in the body, so like an organ crosstalk. So if we can find markers, just like leptin, right? So you have from the white fat, which is sending a signal to the brain saying if you're hungry, or so in the same way, we think that the brown fat is also talking to other organs in the body, and we should be able someday to find a marker by which we can actually both measure how much brown fat do people have. This is my wish list, you can hear.
Okay.
Yeah, so we can measure how much brown fat do people have, like a marker for that, but also to maybe produce a drug for this, so you can activate your brown fat and increase your metabolic rate. So that could be really interesting for obesity and type 2 diabetes subjects. So.
If we did have the ability to measure the brown fat, through what method would we use? Would it be like a blood test biomarker, or would it be actually a physical, scanning the body? Like, what would it look like?
Yeah, so it's a really good question. Lots of people ask me this, can you measure my brown fat, or is there any way that I could go to my doctor and have this measured? It's not possible yet. So that's why I'm talking about this marker. It would be really cool if we can find something that we can go down to our doctor and say, well, how does my brown fat look? But at the moment, we only have the golden standard, which is really not feasible to do in all people. But we have this PET-CT scanning, which is the golden standard. Right. So what we do in research, and we of course get ethical approval to do this, but we cool people I do it for a couple of hours, just a mild cooling, it's called. You look like one. Yeah. And they volunteer, it's crazy. But wow. They lay in the bed, and then I have these cooling mats, and then I cool them for some hours, just very slow, and then we give this radioactive injection, which is a glucose tracer. And this glucose tracer looks like, it's a glucose analog, you can say. So it looks like glucose. And we should remember now, so when we are cold, the brown fat gets activated. And the fuel for activation in the brown fat tissue is glucose. So the brown fat takes up glucose from the bloodstream to keep it active and produce heat, right? Because that's the end product. So when I cool them, I inject this tracer, which is glucose and glucose analog, and then that will get into active tissue. So it will get into the tissue of the brown fat, and then an hour later, I will put them in a scanner and see. Then I can see where the glucose analog is placed in the body. In that way, we can measure how much brown fat do these subjects have. But that, you can hear, is not feasible for just everyone.
It sounds very time consuming and very difficult and very impractical.
Yeah, it's not feasible. But there's another way, which is also measuring with thermography. So you can measure the heat coming from the brown fat. And that is one of the main also methods in my study, because I did a multi-method study. So I did the glucose tracer and PET-CT scanning, also MR scanning, and the thermography scannings, you can say, of the heat coming from the supraclavicular brown fat. And I measured the temperature coming of the skin, because the brown fat is located just beneath the skin, actually. So I measured also how far down from the skin the brown fat is located, and it was, in my subjects, just a millimeter under the skin. So it's up to the skin, actually, in these subjects. And when you activate it with cold, then the heat is the end product, you can say. So with thermography, I could see how much was the temperature increasing with cold, and then again I heated them at the end, and then I could see the temperature in the brown fat was going down again, and then the temperature on the arm was going up. So it was kind of like this with the temperature on the arms and legs, and with the brown fat, you can see the temperature was going up with cold. So that's another way, but it's really, it's a difficult technique, and I practiced for a long time before it really, made sense.
So in your opinion, what does the perfect way to assess brown fat? What might that look like? What might that look like in the future?
The perfect one would be if we could just measure that in a blood sample. So
in a blood test.
Yeah, in a blood test. Yeah.
Oh,
so
wow.
Going down to your doctor and say, I would like to measure my brown fat. It would be really cool if we could find a marker that says,
right.
Yeah, saying that this is a brown fat marker. We can from this blood sample, or maybe 2 or 3 different kinds of markers coming from the brown fat, say, well, it seems like you have this much amount of brown fat. Something like that, but that's in the future, I think. But we are looking into markers already, so it should be. Yeah, it's a wish list, as I said before.
Fingers crossed. Fingers crossed. It's in the next maybe year or two, because then I think that will be a really highly requested blood test from the doctor, instead of them checking just the basic things. Now they're going to look into things that, as you mentioned, the most exciting thing that I think is that organ crosstalk, the ability for this brown fat to then signal to maybe the heart, the lungs, liver, to maybe, does it even affect fatty liver disease? All this awesome research.
Yes, exactly. Yeah. And it's very likely that it has this organ crosstalk, because the brown fat is located very centrally in the body, just there is around the central nervous system. So it seems like it's really, really important regarding it has a very central placing in the body regarding all the other organs. So it's very likely it has some effects, some crosstalk to other organs too. So
did you ever look into specific other? I know I sent through one medication that might be able to stimulate the brown fat production. Did you ever look into actual other modalities to do that, or was it just through cold therapy?
Well, the most, you can say, safe and efficient way of activating the brown fat is still the cold, because of the increase in norepinephrine. And it's just very certain that if we get cold, we activate the brown fat. So we have, I think there are some studies showing that you can activate also the brown fat with some medication. But the problem with those is that you activate your sympathetic nervous system, and also you will have an increase in blood pressure and heart rate, and you really don't want that to be chronic. So it's not something you want to be chronic. You want it to be able to switch on and off, you can say. So it's there's not a perfect way, but still the perfect way is the cold, because you can control that, and it's not too much, and it seems like it's working in different ways. So people can go into the lake or the sea, a barrel or two, or they could go in a shower. So it should be feasible for everyone to do this, or just a foot in a bucket of ice water, right? So it's you can do that in your living room. It's not. You can do something to increase your metabolic rate. That's just what I'm saying. It's not that difficult.
That's great. I think that message is really, it's going to hit home for a lot of people, because I think a lot of people get overwhelmed and they think it has to be super extreme, or it has to be like those cryotherapy chambers. You've probably looked into those, and I'm sure you get asked about those. But have you actually looked into what occurs, the differences maybe with those cryo chambers at all?
I haven't really looked into that much. I think I want to do that a little bit more, study that. And regarding the brown fat and metabolic rate, I haven't really seen anything really convincing yet. So, but I'm still looking. So if people know a paper or something, just send them over to me. I am looking at it at the moment, but I can't really say that it's doing the same or anything. So the thing I think is that it's important for the submersion in the water is that you activate your central nervous system, which I'm not really sure happens in the cryo, but something else is probably happening. So, and you will have the activation of the cold receptors in the skin. So, but no one has measured the brown fat in that regard. So, yeah.
Fascinating. All right. Well, I think that's pretty much everything. Was there any final, maybe areas you wanted to mention for my audience if somebody's looking at actually getting started? What's maybe a few tips you can suggest?
Yeah. So I write tips on my account, of course, but I've written a book. It's translated now, it's getting translated into 13 languages. And I will have the English version out in September 2022. But you can go in my bio and you can pre-order the book. In the book, you will have, you can say, a guide to how to get started, and also how to winter swim, why is it good for you, both the cold, but also a bit about the heat, so going into a sauna. So it's kind of a book where I just tell you what has research found up until now. So the health benefits, how to get started. So if you are a winter swimmer, you will probably nod a lot and feel that, oh, right, this explains what I'm feeling. So it's about the physical health of winter swimming and sauna, but also the mental health. So so you can read that or order it already.
Sure. Well, I'll make sure to point my audience over to your page, and make sure they give you a follow. And with any future research that you publish, I'll be sure to share that on my page, because your profile, you're doing an amazing job at getting the message out there. And what I think you're putting forward is very practical, and that's what I really respect. You're merging a lot of the research with the practicality. So that's something really, really awesome. So thank you so much for jumping on, and we'll definitely stay in touch.
Yeah, thank you, and thank you for inviting me, and thank you for listening.
No worries. Well, thanks everyone for tuning in. We will make sure this IG live is saved for those who may have missed it. But that pretty much wraps it up. Thank you so much, Susanna.
Thank you. Bye-bye. Have a nice day.
Take care.
Take care.